In this lesson, we'll tackle big idea number 1 and number 2. So, how are organic compounds classified, and how does the structure determine its physical and chemical properties? We're going to start with learning target number 1. After today's lesson, you can provide the proper name, diagram, and chemical formula for a compound in the alkane family. Alkanes are aliphatic hydrocarbons that only contain single bonds. That's how you know it's an alkane. Since each carbon is bonded to the maximum possible number of atoms, alkanes are described as being saturated compounds. You might have come across the terms saturated and unsaturated when you were talking about fats in nutrition or in biology class. It's the same thing. Saturated fats have all single bonds. Alkanes vary by the repeated unit of a CH2. So they're what's known as a homologous series. And they have the general formula CnH2n plus 2. That means if I know the number of carbons in my alkane, I can quickly figure out how many hydrogens it has by timesing it by 2 and adding 2. Now, naming alkanes. Scientists use what's known as the prefix, root, suffix method for naming all organic chemicals. The name really describes the structure of the compound, and you should be able to take a chemical name and draw it once you have it. Now, the root part of the name describes how many carbons are in your main chain, or the backbone. The suffix tells you what organic family the molecule is in. And the prefix describes the type, the number, and the location of any branches on your compound. The naming rules for organics use alkanes as the base molecule, and then you add other rules for different families. So here are the steps for naming an alkane. Step number 1, you have to find the main chain, which is the longest consecutive chain of carbons. You use the appropriate organic prefix for the root name. If you've got 1 carbon, it's meth, 2, eth, 3, prop, 4, bute, 5, pent, 6, hex, 7, hept, 8, oct, 9, none, and 10, dec. Step 2, determine the suffix based on your family. Because we're dealing with alkanes, which have all single bonds, our names will end in ane, A-N-E. Number 3, you number the main chain, and you start by the end that gives any branches the lowest possible number. And number 4, you write the prefix by naming each branch as an alkyl group. You use the organic prefix for how many carbons you have, and you add a YL. That signifies that it's a side chain. And you put a position number in front of it. What carbon is it attached to? If there is more than one type of branch, you write the branches in alphabetical order in the name. If there is multiple of the same type of branch, you use a molecular prefix, like mono, di, tri, tetra, in order to indicate how many you have. And finally, formatting. You always put commas between numbers, and you put hyphens between numbers and letters. Now there's a lot of rules there, so let's do some examples. Example A. I need to find my longest consecutive chain of carbons, so my main chain. That would be going straight across the page here. And I've got 1, 2, 3, 4, 5, 6 carbons. So the root of this compound is going to be a hex. And because all of those carbons are single bonded to each other, I have the suffix ane. It's an alkane. Now I don't have any other carbons hanging off as side chains, so my name is complete. I don't need a prefix here. So example A is hexane. Example B. My longest consecutive chain of carbons is the 4 going straight across the page. And then I have a 1 hanging off as a side chain. So the root of my name, if I've got 4 carbons, it's going to be a bute, single bonded together, ane. Now I need a prefix to describe that side chain. Rule number 3 says I number my carbons so that my side chain gets the lowest possible number. If I start here and number them left to right, I'll have carbon number 1, 2, 3, and 4. So my side chain is going to be on carbon number 2. My side chain only has 1 carbon. So meth, and I put a YL there to represent it's a side chain. So I have a methyl butane. And it's on carbon number 2. And I always put hyphens between numbers and letters. So example B, 2-methyl butane. Example C. My longest consecutive chain of carbons. I could go 1, 2, 3, 4, 5, or I could go 1, 2, 3, 4, 5, 6. Remember, the main chain does not need to be straight. It could be kinked, so don't get fooled. Always look for the longest consecutive chain. That gives me a side chain of 2 carbons there. Now because my main chain has 6 carbons in it, the root is going to be a hex. They are all single bonded to each other, so ane as my root. Now, if I start numbering my carbons 1, 2, 3, that will give me a lower number than if I start here and number them 1, 2, 3, 4. You can start numbering from either end. Always pick the one that gives you the lowest number for your groups. Now because my group is 2 carbons long, it will be called an ethyl group. And it's on carbon number 3. So 3-ethyl hexane. Unfortunately, when you write the names backwards, like I just did, sometimes you end up with some extra space. There should not be a space between your name. Now, I would like you to try out example D and E. They're harder ones with multiple groups on them. Try them out and get the answers in the next video. Here's the answer for example D. My main chain is right here, 7 carbons long. Now if you want to, instead of going from down here up, you can go from this carbon down. You'll get the exact same name that I will. That gives me that side chain, and that side chain. If I have 7 carbons in my main chain, it will be hept, all single bonded, so my suffix is ane. I have 3 groups that are the same. They all contain 1 carbon. Because they all have 1 carbon, they are methyl groups. Because I have 3 of them, I'm going to stick the molecular prefix tri in front to designate that I have 3. Now I have to add position numbers. If I number from this end, I will get lower numbers. I'll have a 2, 3, 5 as opposed to my first one if I start counting from this end at carbon number 3. So the name for D is 2,3,5-trimethylheptane. Now for example E. My main chain will be the 8 carbons as highlighted. That gives me a group here, a side chain here, and a side chain there. Because I have 8 carbons, my root is going to be oct. They're single bonded, so my suffix is ane. Now I have 2 different groups. I have side chains with 2 carbons and a side chain with 1 carbon. I have to put them in alphabetical order. This will become an ethyl group. This will be a methyl group. And alphabetically, E comes before M. So because I'm writing my name backwards, I'm going to start with my methyl. I have one of them, and I got to work out my numbering. If I start from this end, I'm going to have 1, 2, 3, 4, 5, so groups on 3, 4, and 5. If I start from this end, 1, 2, 3, 4, it's going to be 4, 5, and 6. I have to start numbering from that carbon. So my methyl group is going to be on carbon 3. And I have 2 ethyl groups, each one 2 carbons long. So because I have 2 of them, I'm going to use the prefix di in front of my name. And those ethyl groups are on carbon number 4 and carbon number 5. So the answer for E is 4,5-diethyl 3-methyl octane. Now, the names of organic compounds are so complicated because they describe the structures. You can take a name and go backwards and draw the structural diagram. So here are the steps. Draw the main chain horizontally across the page. It makes it easier than drawing it kinked. Step number 2, add branches on the appropriate carbons. In step number 3, add enough hydrogen so each carbon has 4 bonds. So let's draw 3-ethyl 3,4-dimethyl hexane. So notice in my name the root is hex, so that means I need to draw 6 carbons straight across my page. Now, if I start by numbering them left to right, so this is carbon 1, 2, 3. I need an ethyl group on carbon number 3. Eth, remember, is 2 carbons long. Now, also on carbon number 3, I need a methyl group, which is 1 carbon long. And on carbon 4, I need a methyl group. Now remember from our last lesson, because of bond rotation, it doesn't matter if I draw the methyl going down or up or the ethyl going down or up. Same on this one. Any orientation works. Now to finish this diagram off, I look at each carbon and add enough hydrogens in order for it to be stable. Starting with carbon 1, it has 1 bond, so it needs 3 carbons to be stable. So CH3. The next carbon has 2 bonds, so it needs 2 hydrogens. This carbon here already has 4 bonds, so it doesn't get any hydrogens. Now, by following this process, you can complete your diagram. I want you to try out example 2. Draw 3-ethyl 5-propyl decane. So here's the answer for example 2. Because my root is dec, I should have 10 carbons in my main chain. And I need to have an ethyl group, which is 2 carbons long, on carbon number 3. And prop means 3, so I need a 3 carbon group on carbon number 5. Now, properties of alkanes. Remember when we look at properties, we describe the intermolecular force and compare the strength of that force between 2 particles or between a particle and water. Now, for melting point, what force can an alkane use to attract another alkane? If you check the electronegativity difference between carbon and hydrogen, it's 0.4, which means it's a nonpolar covalent bond, which means there's no charges on an alkane. This means that they only attract each other using London dispersion forces. Therefore, they have low melting points because Londons are a weak attractive force. Now, in terms of solubility in water, alkanes are nonpolar and water's polar. Therefore, it's attracted using weak dipole-induced dipole attractions. Therefore, alkanes have low solubility in water. Other things you should know about alkanes. We mainly use them as a fuel source. We do combustion reactions with them, which releases large amounts of energy. So where do we use them? Well, we use them methane, which is the simplest alkane, as the main component in natural gas. So what burns in your furnace, if you have a gas furnace, or in a gas stove, or coming out of a Bunsen burner. We use propane to cook things in our barbecue. We also use gasoline, which is an alkane. Main component is octane, which drives engines like the ones in our cars.